This is Juan Garcia from SC311. This is the video representation of Homework 4. Homework 4 has several requirements, including using the MVC pattern, given here with the calculator view, controller, and model, where the view is responsible for the UI. Calculator controller is responsible for interaction between the view and model. That is, when a calculation occurs, it'll update the view. Likewise, if the clear button is clicked, then it'll update the model and nullify some of these variables. Another requirement was the composite pattern. In this case, calculator model aggregates the composite pattern. Composite pattern is shown by the abstraction math expression and number and operator that extend that expression. As you see here, get children, accept, get string, set string representation. These are all their own implementations. For example, get children would return an array list, but it would be null, whereas operator would return get children, which would be the first operand and the second operand. Another requirement was using the visitor pattern, which is demonstrated here with the use of math visitor and the two classes that implement the interface, print visitor and calculation visitor. Print visitor, as its name suggests, will print to the console and return a string that, when the calculation is successful, will be given to the server. Another requirement was using the client-server architecture to send an equation to the server. Here you'll see the client that is responsible for communicating with the server. Furthermore, the observer pattern was to be used. Two components to the observer pattern are an event and its list of observers, or classes that subscribe to that event. In this case, calculator controller subscribes to the click event. Click event is literally just clicking any of these buttons. Given that this is Java and we're dealing with a user interface, a GUI, action listener is also used. That is, action listener will trigger the action performed, and action performed then calls process event. This process event will update as given by the observed clicks, and will give calculator controller the button that was just clicked. In this case, it's a math expression. The update is then used to interact with the state, as will be shown later. As for state, the classes that implement it, like start state, get first operand, wait for next operand, etc., are all based off of the DFA given for homework 4. So in start state implementation, the transition to getting first operand will only occur if an operand is given. Likewise, to transition from get first operand to wait for next operand, this will only occur if an operator is given. Now that we've talked about the UML and how the patterns are used, let's run the actual server and client. So there's two things to note. Since this is a Maven project, you should see a server-side jar. Furthermore, you can find this in the calculator server-side target folder. So all you got to do is simply run this Java jar, and you can now see that the server started and it's waiting for the client. To start the client, just go to your IDE and run the driver that's part of homework 4. So here we'll just run as a Java application. And you will see that the calculator UI will show up. Now let's run through some of the requirements. Here we have C1, C2, and C3. Let's begin with those. C1 says that when 3 plus 5 equals 8 is given, you should see 8 in the display, and since this is a successful equation, we're going to send that to the server. So currently the server will have one equation and it'll display that equation. Let's look at C2. 33 plus 55 and equals should display 88. So let's clear 33 plus 55 equals 88. Again, the server will display that it has two equations and display those equations. I took the server to do these two things whenever an equation is given. Let's look at C3. 4 plus 5 times, and it says at this point 9 should be displayed, 6 equals. Let's clear our calculator. 4 plus 5 times, we see that 9 is updated. Now we're going to do 6 equals 54. Again, successful equation, server is updated. Let's clear once again. So we've cleared, and now the user is going to click a non-digit button. Times, divide, minus. Nothing happens. And if you've noticed, the calculator or the console displays in start state and start state. That's because if we go to start state, you'll see that the transition to the next state only occurs if the value given is an operand. Otherwise, nothing happens. Again, this is modeled off of the DFA given here in homework 4. So now that we have that, let's look at C5. At any state, the user is going to click clear. So let's go look. 5 plus 9, clear. Panel is empty, nothing shows. But now if we start up again, 4 plus 5 equals 9. So the clear is correct. If we clear here, 8 minus 2 plus 5 minus 9, clear. Nothing shown. But once we start up again, shall see 5, and the equation is given to the server. I did not implement C6 or C7 for this homework. However, C8 and C9 have already been shown, but we will do that again. So a successful calculation occurs. 5 plus 2 equals 7. Now we're going to click a digit and it should get ready for a new calculation. 2 plus 3. That works. Now let's look at C9. The user clicks a non-digit, the system resets and displays nothing. So it's clear, minus, times, plus. Again, you shall see in start state that it will not transition. So 5 plus 9 equals 14, minus nothing. Cannot proceed. Again, C8 and C9. So let's take a quick look at the calculator controller. And like I was saying before, the update will be triggered when a button is clicked. The thing here to do is recognize whether it's an operand, an operator, clear. If it's a number, we're going to give that to our current context, which will handle it. As mentioned previously, this current context depends on where we are in our DFA and follows the DFA given in homework 4. An operator, same idea, it's given to our current context to handle and will only proceed if appropriate. Print visitor has the purpose of adding to each expression or adding each operator operand to the expression and then returning that string. So for example, we're going to call our full expression, which is gotten from the e.getFullExpression, and we're going to call except on each one. If it's a node, you're just going to get a string representation. If it's operator, you're going to get string representation as well. That's it for homework 4 video demonstration.